Hello and welcome to another Wednesday webinar. My name is Jason Gagan. I'm the Vice President of Commercial Sales for our Manifold Group. If this is your first time joining us, a special welcome to you. Do want to get you a couple of housekeeping things covered before we get started. If you're unfamiliar with the Zoom interface, though I'm sure you've seen hundreds of these, just want to understand how we use it. There are two buttons on your ribbon there. One is the Q&A button. That's going to be a great place for your questions throughout the presentation. We do have a couple of panelists online with us. Zach and his team are joining us today, and so we might answer those in real time, or we might save those till the end when we do our Q&A session. The second button is the chat window. That is a great place for technical issues if you can't hear, if you're having trouble with the videos, or with the screens. Definitely put a message in there and we will do our best to try and fix those technical issues. To kind of give you a understanding of who we are and what we do, our Manifold Group is a pressure-based controls manufacturer out of Fort Worth, Texas. We go to market under 3 different brands. LF Systems focuses primarily on commercial dryers, high-rise exhaust, stairwell pressurization, and elevator hoistway pressurization. KW USA is a partnership with Kutzner and Weaver. That's a German manufacturer. That brand focuses primarily on fireplaces, pizza ovens, some specialty products. And then the brand we're going to talk about today is US Draft Co. US Draft Co. is focused primarily in the mechanical space. We're going to use the term boiler a lot throughout this presentation. It really pertains to any fuel-fired equipment. So that's boilers, water heaters, pool heaters. Sorry, I did see that there's a hand that went up. If you could go ahead and put your question in the chat, I would appreciate that. That'd be the easiest way to get that over to us. But anyway, so my background is primarily in the boiler room. I was born and raised. Sorry, real quick. The question came in. Is your computer mic muted? Yes, everyone's mic should be muted by default. And you have to get permission to get that removed. So you're good to go. The guy who put that in the chat. So anyways, I was born and raised in the boiler room. My father was a licensed plumber in the city of Chicago, which is where I grew up. Immediately got out of school and went into the industry doing working in the wholesalers, doing water heaters and furnaces, unloading those things out of semis. Immediately kind of worked my way into inside sales, outside sales, working with designers and engineers throughout my 29-year career. So most of what I've learned has been industry taught. And so we're going to kind of use some of that knowledge to talk today. We're going to talk about some general venting listings. We'll get into the categories of appliances as well as some of the formulas we use. Mechanical draft fans, dampers, and controls. We'll talk about our connector draft system. And finally, wrap up with some boiler room safety. So when it comes to creating an appliance, there's 2 avenues that a manufacturer can go down. One, they can be a ANSI Z21 categorized appliance. The other as a UL 795 building heating appliance. So basically, if the burner is integral to the boiler, if that is part of the package, and you don't have much choice on that, that's most likely going to be a categorized appliance. If the burner is external to the boiler, it's most likely going to be listed under UL 795. Now, there are exceptions to that. I can think of a few condensing dual fuels that come with an external burner. And there's some limitations on how to do that. But just know, in general, that is kind of that rule of thumb. When they were putting together the categories for this, they're real creative, calling them categories 1, 2, 3, and 4. I could read this list for you if you'd like. That'd be really boring, especially right after lunch for some, I guess. So instead, we're going to use this handy-dandy cheat sheet. This is a chart that is in the ANSI handbook, and I recommend any designers that handle venting on a regular basis, they should print this out and just understand what each category means. So anything above this horizontal line here is considered non-condensing. Anything below it is condensing. Now, this is, again, your venting system, not your boiler. There are plenty of boilers out there that are non-condensing in the cabinet but could condense in your vent system. And so that break point's about 85%. If you're less than 85%, you're most likely going to be in this upper half. If you're greater than 85% thermal efficiencies, you're going to be in this lower half here. The other factor in this is the vertical line, and that is anything to the left is considered negative pressure. Anything to the right is considered positive pressure. Negative pressure is something pulling the flue products out of the appliance. Positive pressure is something pushing those flue products, typically a fan internal to the boiler. There's really two types of vent material you'll have to worry about. So category one, that's your typical draft hood or fan assisted vertical termination appliances. That's going to be your standard UL 441 B vent. A lot of people are familiar with B vent, and there's an entire chapter in code on how to design B vent systems and how to size based on lengths and elbows and all of that. The other three categories all fall under UL 1738. So that 1738 handles categories 3 and 4 for the pressure, and 2 and 4 due to the corrosiveness of condensate. Most people consider this the AL 29.4C categories, and that is true. AL is under UL 1738, but 1738 does not require you to be AL 29.4C. There's several other manufacturers that use different materials, 316L, 444 stainless. There is a plastic blend called polypropylene, and there's currently one manufacturer of a UL 1738 listed PVC. It's not your traditional white pipe that you see in your hardware stores. It's a very specific brand that does have that 1738. Now, there's tons of limitations on that, and that manufacturer can give you what those are. But if you're not using that specifically listed product, then PVC is not a viable option for venting. So much so that the largest pipe manufacturer in the world decided to put out a memo several years ago saying that this is not a valid use for their product. And the reason being is that the melting point of PVC is about 149 degrees at atmosphere. And what happens is if your flue temperatures start to exceed that, you could actually melt the pipe from the inside. And it doesn't melt like you think of a Bic lighter and a straw. It's more of a where the molecules internally change to where you're no longer are a PVC. It's just a very brittle plastic. Many guys will say, well, that's why we don't use PVC. We use CPVC. And it does push your temperature limits a little higher, get you up to about 190. But again, the same issues apply. And to curtail that, what the boiler manufacturers have to do is they have to actually put a temperature sensor in their flue outlet, and that will either derate or shut off the boiler if the flue temperatures start to exceed that temperature rating, start to exceed that internal temperature. And so typically your flue temperatures start to rise based on water temperature. So here's a scenario where you have a outdoor reset system, and in the spring and fall, system works just great, but in the wintertime, you might start having intermittent dropouts. Well, why is that? Well, because your water temperatures, return water temperature rises. That means your flue temperatures rise, but the boiler can't handle that, so it starts to derate itself. So then the boiler says, I have to work even harder, and starts, trying to, turn the output up, but then it starts to derate again. So it becomes this fighting issue of trying to get to set point while also maintaining that minimum flue or that maximum flue temperature. So easiest way around that is just use a UL 1738 listed product, and then make sure that that product is listed for the temperatures that you're planning on seeing. When you get into the bigger boilers, UL 1795 or 795, excuse me, this is again your big fire tube, water tube type products. They have higher temperature ratings, and they also have higher pressure ratings. That falls under UL 103. A lot of times the guys will say, well, it's non-condensing and it's positive pressure, so it must be a category 3. And if you recall back to that, that would be an accurate statement that a category 3 is a non-condensing positive pressure. The problem is because of the temperature ratings of these larger boilers, 1738 just doesn't cover that. So you have to get into a pressure tested chimney. And there are so many different options. Most of the time, that inner wall is going to be 304, 316 stainless. The outer wall is made of So many different options: gal aluminum, aluminized, 304, 316, 444, I think is another one that some of the guys are offering. It is pressure tested up to 60 inches, but please do not put that in your specifications for boilers. That is more for generator exhaust, where you cannot have slip joints. So don't put that in there, but just know that the product itself is rated for a very high pressure rating. 1-inch air gap all the way up to a 4-inch fiber insulation. Depends on your application, depends on the product that you're using, depends on the manufacturer of both the appliance and the vent pipe to determine what their temperature ratings are based on what you're using. So again, if you're doing a water boiler, your 1-inch air gap is probably going to work just fine. If you're using a superheat steam boiler, you might have to get into 2-inch, 3-inch, or 4-inch. And then that gets into clearance of combustibles and all that good stuff. So best answer is work with your venting manufacturer or your local rep to determine which pipe is going to be most applicable for your project. So when it comes to sizing vents, there's pretty much two things that we use: NFPA, the National Fuel Code Handbook, and ASHRAE. Basically, NFPA tells us what we can and can't do, and ASHRAE tells us how to do it. And if you've ever looked into the ASHRAE handbook, you'll possibly have recalled seeing this really long formula, a whole bunch of letters, numbers, and symbols. And as a proud member of ASHRAE, I can tell you that there's a problem, and the answer to that problem is at the bottom. This does not consider any modulation, any time, prime time, anything like that. It's basically a snapshot in time. And so while this gives you an idea of what your chimney is going to work, or how your chimney is going to work, unless you're doing an on-off boiler and it only works at the same temperature outside every single day, this is going to be, this is going to continuously change. But it's a start point. So we'll use that as a base point. We can determine our pressure loss, again, through a whole bunch of letters, numbers, and symbols. Good news is we have a lot of great softwares out there, including our calculator, that can help you determine all of this. And finally, we have to figure out theoretical draft. Theoretical draft is based on two things. One is the height of your stack, and the other is the delta between ambient and flue temperatures. So the taller your stack, in theory, the greater your draft is. And I say in theory because at some point, it's so tall, it starts to cool the draft down, so that offsets, right? So again, then the greater the difference between ambient and flue temperature, the more natural lift you get. That is why an old fire tube boiler will have better natural lift than a new condensing appliance. I get a lot of projects that I've dealt with in the past where they had an old, 75 to 80% efficient burner. They go to a low NOx burner, and because that, your flue temperatures are lower. More recirc air is put into the appliance to get your NOx levels, which means your flue temperatures drop, which means you have less natural lift. Same thing with taking out a cast iron boiler or a category 1 appliance and going to a new condensing type appliance, throwing a stainless steel liner, and you're not getting that natural lift, and you don't know why. Most likely it's because your flue temperatures are dropping, which is a good thing. You want more of that temperature to go into the fluid and not up your stack. So as a boiler guy, I always tell people that if you can vent appliances naturally, please do that. You can do it within the appliance's recommended procedure, do so, okay? Single appliances up and out 12 feet works fantastic. The problem is, as designers are squeezing less and less room in mechanical spaces, or more retrofits than new builds, which means you're put in positions where you may or may not be able to reach or stay within those limitations. Then you start getting into common venting. And most manufacturers, once you start common venting, now require some kind of an assistance. And the reason for that is because your pressures are always changing. As boilers turn on and off, modulate up and down, your pressures can be anywhere from a 0.15 negative to a 0.12, 0.13 in this scenario, positive, okay? And so we want to try and smooth that out. And by doing so, one way of doing that is with mechanical draft fans. So our vent control system consists of 3 different options. We have a termination style fan, 2 inline fans. All of our fans are listed to UL 378 and 705 as required. And by code, you must go through an appliance interlock controller. You cannot just put a fan on a boiler and hope for the best. You'll see these little booster fans that just turn on and turn off. You have to have some way of interlocking, or excuse me, just leaving it turned on and letting it go. You have to have some way of interlocking that to the appliance so that if the fan does not function, it does shut the appliance off. This is a very simple, typical layout. You've got 3 appliances, all into a common header. Fan, this one's showing the termination style, wired in through our pressure controller, transducer reading pressure at the end of the common stack. Very simple sequences. Boiler gets a call for heat, sends that signal over to the controller. Controller turns the fan on. Fan does its pressure checks, verifies through the sensor, through the controller, and allows the boiler to fire. And this is all going to happen within a couple of seconds. As soon as that happens, boiler gets ready to go through its sequence. First step that it does is it goes through a pre-purge. By code, you have to turn the air chamber over 3 to 5 times in the boiler, depending on the type of appliance it is. And so when that happens, you'll dump a whole bunch of ambient air into your stack, changing the temperature, volume, and pressure in that common. So obviously the controller is going to see that change and ramp the fan up. Boiler goes to light off, it'll pull back down, and just find its steady state of operation. As boilers turn on, ramp up, again, whatever this set is, that is what we're targeting. We don't really care how many appliances are running. We're just trying to maintain a pressure in this common. And the theory is that the boiler can actually vent itself to the common, right? So as long as you keep this within its operating parameters, the fan will evacuate the common header, the boiler will vent to the common header. Our termination fan goes up to 19,000 CFM. I can tell you that we've only sold a couple of those, very large fans. But if you have a larger project where you need several thousand CFM, we can do those. Up to 1,000 degrees. If you have a 1,000 degree boiler vent, you probably have an issue. These are mostly to meet projects where you're using a 1,000 degree stack. So we're just offering that as an option. EC motors up to 1 horse. That's about 2,500 CFM. And then we use traditional 3-phase marathon or WEG motors beyond that with the VFD. 430 or 316L stainless, I would say 85% of our business is in 316L, mostly due to the corrosiveness. We want to make sure that we can handle the corrosiveness of condensate. Our inline fan is a true inline fan, so it shares the X, Y, and Z plane. Up to 9,000 CFM. Again, 378 and 705 as required. Same motor options, same metal options. You will notice that the frame of the fan does look a little wonky, and that's again to make sure that your inlet and outlet share that plane. And this was a great retrofit option. We did a project where they had 10 different appliances that all needed fans after the fact. They had already hung 150 feet of pipe and realized that they were way too far. So all they did was they took out a piece of pipe, added a couple of adapters, popped the fan in place. They had all 10 of them hung within a day and a half. Still had some wiring and finish work to do, but it actually kept the project moving right along. So that worked out really well. Another inline option would be our 90-degree fan. That's the T9F. This design goes up to about 5,000, 5,500 CFM. And then we have another frame style centrifugal fan that goes up to about 16,000. Works really well on a rooftop coming in from the side and then discharging vertical. Again, same motor options, same metal options. So when you don't have enough pressure, right, you're not getting enough natural lift, the fan works really well. Obviously to draw that mechanically out, but sometimes you're going to get into situations where you're overdrafting the system, where you'll have too much lift. And that may be a perfect scenario where you're using it year round. So you kind of size for for all appliances, but in the springtime and the fall, you're not getting enough natural lift. So you have a fan up there. But in the wintertime, when it's super cold outside, the return water temperatures are raised. That means your flue temperatures are raised. You're going to get a nice natural draft. Once that chimney gets primed, you'll start to take off and start to get into the deeper negatives. So we have to slow that down a little bit. And we do that through a mechanical damper system. This is our inline overdraft control system. Back up here. And basically, we're going to do the opposite that we do with the fan. As the pressure starts to build, right, we can turn the fan on and draw that out. But as the pressure starts to go deep negative, we'll slow that fan down to its lowest speed and then start to mechanically create back pressure in that system. So we slow that draft down. We use a multi-blade opposed blade design damper. It's all 316L stainless steel. We help design the fast acting actuator. It's 2 seconds full open to full close and vice versa. So obviously as things are changing, it's changing in an instant. Rated for 1,000 degrees. Again, we're just trying to make sure that we're rated for the most traditional temperature of the higher temperature venting out there. We can also use this as an on-off damper with an optional in switch to make sure that we can improve open or close. 2 things I do want to point out, not sure if it shows through the Zoom or not, but all of our inline products come as a raw collar, and that is so that any vent manufacturer can adapt to this. Again, depending on which manufacturer you're using, just tell them, hey, we're using a US draft damper. It's the OBD with a raw collar, and we have a relationship with many of the manufacturers that they know exactly what they need. If you require a flange adapter, we can provide that as part of our damper. Second thing I want to point out is these drain plugs. All of our inline products have inline drains that is designed to drain the product only. It is not supposed to take the place of your system drains. So again, every vent manufacturer has their guidelines as to how much drainage you need based on the length of your horizontal or vertical runs. That still is, you still need to follow those guidelines from them. This does not replace that. Okay. So when it comes to controls, this is kind of where US Draft really made a name for itself. The reason for it is prior to us existing, the technology that was out there was all negative pressure. So everything was running between 0 and 0.6 was kind of the range of the controls. And that worked really well for category 1, where you'd set that thing to a 1/4 inch negative, throw a barometric on the boilers, and keep it about 1/10 inch negative. Everything worked great. Unfortunately, for them, for this technology, we've surpassed that to where many of these appliances now want to run close to neutral. And so we will set our common header for, say, a 0.04 just to create a very slight negative. But as a boiler turns on or as the appliances first start up, the pressure in that stack will exceed neutral, right? It'll start going positive. Unfortunately, the controller doesn't see that change. It stops at 0. So it doesn't know how far away from set point it is. It just thinks it's 0.04 of an inch. So it slowly ramps that fan up. Now, eventually it will get there, right? With us, we actually read plus or minus 1 inch, and we have from the outset, okay? So we actually see that spike in pressure, react to it typically 50 to 60% faster, and get us to set point. Now, full disclosure, if this is a single appliance, this system will probably work just fine because this will all happen during the pre-purge cycle. And the appliance won't, if the appliance has a block flue switch, it might cause an issue. But if it's working off of the draft controls, safeties, should be fine. However, where the issues come into play is when you get into common vented. So if you have one appliance running and it's setting, at a 0.04 or whatever, and then the second appliance goes into, gets a call for heat, decides it's going to run as well, that's going to dump a whole bunch of cold air into this common. So now there's a huge addition of volume, changing temperature, changing the pressure, and it can actually backfeed and cause that blockage, cause a greater blockage on that running appliance. And typically a block flue switch is not a manual reset thing. So it'll shut off, but as soon as the pressure drops, it'll try and fire again. Or if it's in a sequencing scenario, it'll let boiler 2 fire and then try and turn on boiler 3 and cause the same issues. And you could start short cycling these appliances purely because you're going off on a block flue, but that is not a registered alarm on the controller. And so it just cycles and cycles and cycles until it just finds that perfect spot to where they can run. So there's a couple of ways to overcome that. One, you can oversize this common so that you don't have, so there's not as much change in the volume. You have more space for that change to occur. Or you can run with a true bidirectional control system. The other primary thing that I talk about is if you were to select a temperature gauge for a water pipe on a 100-degree water pipe, target, you wouldn't put a 105-degree thermometer on that or 105-degree temp gauge, because you would never know, you wouldn't have the range that you desire to really see what's going on. So with a negative pressure only, if your set point is a slight negative, you're going to hit that ceiling fairly quickly. Again, with us, we're basically right in the middle. It also gives us some flexibility to, with some of our other products we'll talk about here in just a second, to actually run at a slight positive. And this is true of all of our V series controls. So we have our, our 350, which is our kind of flagship, if you will. It's our high-end controller, but this technology is based throughout the entire lineup. So a true bidirectional controller allows for a high and low pressure safety. We do provide a list of factory defaults so that 85% of the jobs can run straight out of the box, but it also is programmable in the field to adjust based on your needs. So if the sensor isn't in the ideal location, or if the project required a couple extra fittings and now there's a little extra back pressure, so maybe the reaction time has to be a little quicker than anticipated, all of that can be adjusted in the field. We have customized programs for both makeup air, exhaust air, fans, and dampers. So you're not just getting a generic, hopefully it works control program. This is actually specifically built for that application. We have a variety of controls. We'll show you here in a second, from a LCD all the way up to a 7-inch touchscreen. All are UL 508C listed, and Modbus communication is standard. Before you ask the question in the chat, yes, we can do BACnet through a gateway. Again, just a overview of all of the different options that we offer. Our little V150 is a great 2-appliance simple controller. Again, all the way up to the 350, which can do up to 15 appliances. And this is just a kind of a close-up shot of the 300 series. So the 300 and the 350 are exactly the same control, just one has an internal expansion board to handle more appliances. Cool. So many times we get called in because it's a function of the design, right? You can't meet the manufacturer's requirements. The boiler isn't able to run how it's designed to run because the venting is limiting that operation. But in many cases, we get called in because of code. So the boiler itself would work fine, but codes are restricting what that appliance can handle. And the first one is the 10-foot, 3-foot rule. That's my nickname for it. That's not the official name for it. If you read into it, there are certain variables of 2 feet. With something that's within 10 feet, you have to go 2 to 3 feet above it. That's too much to remember. I just say 10-foot, 3-foot. So if that's parapet walls, pitch roofs, cooling towers, anything that's within 10 feet of your vent termination, you have to exceed it by 2 to 3 feet. Of course, you could ignore that code and just do stuff like this. See this one all the time where you'll put they'll just put a chimney cap on a curb. That's not code. This here is prevalent here in Texas, where we'll do some water heaters and they'll go sidewall with B-vent, which is not allowed. And so you tell them that and they say, okay, fine. So they'll put an elbow in a piece of pipe, call it vertical. One, that's not how that works. But 2, you didn't clear this wall here. So now you have to add 2 more pieces of pipe, but the B-vent code says you can't have 5 feet of B-vent exposed. So that causes all kinds of issues, unless you put a fan on it. Same thing here. They tried to clear this parapet, not very well, but they did. They forgot about this wall here. This one I can't fix. I got that picture one day and I have nothing to say about that. So I'll just let you sit back and chuckle for a second, and hopefully everyone was okay. So why do I bring this up? Well, this was a project in the Dallas Metro where there were 2 steam boilers, and you can kind of see the curb over here, the second one. And this was purely aesthetics. They had pieces of pipe actually extend above the parapet just fine, but the director of the hospital didn't like looking at that when he drove in the morning. So he told maintenance to pull that down, and then started wondering why his boilers wouldn't work. So they called us in, and we basically offered the option of, well, you either put the piece of pipe back on, or put a fan on it, and you won't be able to see it. And the reason for that is we're now mechanically inducing the plume to get above that parapet, right? We're not going to have that back pressure that is a possibility with a crosswind. 7 times area rule. Basically, the smallest connector cannot, the largest common pipe cannot exceed the smallest connector by 7 times the area. Simple rule, don't put 4-inch pipe into a 32-inch chimney. This is horribly prevalent in schools where, schools that were built in the 50s and 60s, and they had an old fire tube or an old brick set boiler. They took it out for some category 1s, and now they're taking it out for condensing. And the condensing ones are going sidewall. But they still have this old 40-gallon water heater going in to the side of the brick chimney, which is probably wrong anyways. But now it really doesn't work because there's no other heat in that stack. That is against code unless you put a fan on it. Primary reason for this is because that 4-inch water heater is not going to prime that chimney enough, get enough heat in that stack to get you to a natural lift state. Okay. With a fan, we're mechanically inducing that lift. Now, full disclosure, there's probably better options rather than putting a fan on a 32-inch brick chimney for a 4-inch water heater, but it is an option if you ever get into that situation. Another one says that you cannot have a negative pressure appliance with a positive pressure appliance in a natural vent system, right? So the only way to get around this, again, if you have a category 1 appliance and a category 4 boiler, you want to put those into a common vent, put a fan on it. It is now an engineered system. Okay. You do have to make sure that your stack is rated for the for both appliances, so just make sure you take that into account. So some good venting practices. If you are naturally common venting appliances and the boiler manufacturer tells you to do it this way, go ahead and do it. That's their way of the way that they're promoting, even if it's wrong. When you're doing mechanical draft systems, especially with mine, because my request is that we put a T-cap here at the end. So I have a great location for my sensor. And then now it's only reading pressure. It's not affected by flow. A lot of times what we'll see is it'll be a common header all the way to in between these two appliances, and then it will drop down to that last appliance. It just doesn't give me a good spot for a sensor. I'd much rather go to the end with that T-cap. One thing, if you learn nothing else today, please, please, please put a star next to this note. Lateral T's are your friend. Flue gases are stupid. They do exactly what you tell them to do. So if you tell them to bang their head against a wall on a bullhead T, that's exactly what they're going to do. Okay. That creates turbulence. Turbulence creates pressure, and pressure is bad. Okay. A boot T is not the same as a lateral T. If you look at the K value of these two fittings, they're not identical. Now, a boot T is better than a straight T. A lateral T is better than a boot T. The easiest analogy I can give you, this is a 4-way stop. This is a turning lane. This is a merge lane on the highway. Okay. The flue gases just want to naturally get into the flow here. Here they kind of are, yeah, we'll get there eventually. Here they just want to create chaos. Okay. So please, please, please use lateral T's at any point that you can. Yes, they're bigger. They take up more space. Yes, they're a little bit more expensive. But yes, they are the proper way of doing it, especially connecting to your commons. Now, in many cases, I'll see a boot T on the appliance outlet because you're getting some help naturally going vertical, right? So you're coming out horizontal and then boot T'ing to go vertical. That's totally acceptable. It's really where you're getting into these commons going from a 6-inch to a 12-inch or 8-inch into a 20-inch. And it just naturally flows so much better doing it this way versus a boot T. Okay. Ventral draft. So everything we've talked about so far has been system pressure, right? We're talking about trying to maintain a slight negative here in this common so that the boilers can stay within their range. Okay. And so while that works really well, as energy codes have got, cracked down and as boilers have become more and more finicky, and that's a good thing. The reason for that is because they're becoming more efficient. Well, just like anything else, the more efficient it is, the more difficult it is to stay in those efficiency ranges. But to get to those numbers, we don't really care what's going on here. We care what's going on here. And so we need to maintain pressure at the appliance to make sure that that appliance is always running in optimal conditions. And it's very difficult to do naturally. It's very difficult to do common unless you do what we call our connector draft system. So this is a draft control damper with its own controller, its own sensor, all built in to a complete package, put in the connector of each appliance. So now they're running in almost an independent scenario. The easiest way to describe this is primary, secondary piping for your vent system. Okay. It doesn't really matter as long as the common is more negative than what your desired pressure is. So if your desired pressure is a 1/10 of an inch negative, size this for, say, 2/10 negative. If your target is a 0.1 positive, size this for a neutral or a slight negative. Okay. So it really depends on the appliance that you're using. But the best part is, as a designer, you design it for one manufacturer, but you have two others that you're allowing for quotation purposes, right? So brand A wants to be 0.1 negative. Brand B wants to be neutral. Brand C wants 2/10 positive. It doesn't matter because your design now takes all of that into account with the CDS. This is actually our second generation CDS. We introduced this in 2017 and then launched the second gen probably late 2019. It is a patent pending system, pre-packaged, all stainless steel, 316L. The new style actually is a one-piece damper and test port all in one, using that 2-second actuator I mentioned earlier. So again, at the outlet of the appliance, we are instantaneously reacting to changes in set point or changes in pressure. Can handle plus to minus 1/2 inch of set point. We do have a high pressure option, so we can actually go all the way up to 2 inch on our settings. That can be ordered when you're working on it. Viton seal gasket. So if the boiler's in standby, we are bubble tight seal on that damper. And then for those of you that were in Chicago for the AHR show, you may have saw the reveal of the 3rd generation CDS. This is coming, we'll say soon. Production and engineering is telling me possibly later this month, most likely in April. But again, all of the features and functions that we've had in our first 2 generations are staying with the CDS3. The biggest addition now is that 4-inch color touchscreen. It really takes everything to the next level, just from a programming standpoint, as well as from an operation standpoint. You can see exactly where the damper is positioned, exactly what the pressure is, all on a color touchscreen. Makes it really, really nice for the operators to just scan through each one of them and see what the system's doing. So we'll obviously, follow us on LinkedIn to keep up on that. We'll definitely have an announcement once that's available. All right, boiler room safety. I continuously see various threads on LinkedIn and hear stories about carbon monoxide poisoning. And here in the state of Texas, we've been instrumental in making it the required code in all mechanical rooms. So if there's a fuel-fired appliance in a mechanical room, a carbon monoxide monitor is required. The state of Georgia has now adopted that almost word for word. I think they basically just scratched the word Texas out, put their name in. Many other jurisdictions are looking at it and are reviewing it. In my opinion, it should be national code. Whether it's mine or someone else's is irrelevant. What is relevant is that the monitor is designed for the mechanical space. It doesn't just beep, doesn't just blink a light. It is actually tied into the alarm circuit of the appliance, so that if the room gets to unsafe levels, it shuts the appliances off. The fuel-fired appliances is most likely causing the carbon monoxide in the space. So why would you not control that and shut that appliance off? So with ours, it is a pre-programmed 2-stage alarm. It's programmable to 50 ppm, up to 2 to 5 minutes. If it gets above that level for that 2 to 5 minutes, it shuts the appliances off with a manual reset. If it gets above stage 2, which is factory set at 100, it instantly shuts off. Again, manual reset. It's a dual powered relay. So basically it is powered close, alarms open. What does that mean? Well, if it starts to annoy them, they can't just pull power on the device. It'll open that contact and shut the boilers off. They would have to manually go in and jump out the safety circuit. I always say I can't engineer against stupidity. I can try, I can't always get around that. So please, 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 if you request a sizing design from us, this will be on the bill of materials. We are going to make you request that it's taken off for various reasons. I've been involved in too many situations, one specifically a lawsuit where a life was lost, and I'm not going to do it again. So I have instructed my team that they will provide this as part of the draft control package, and I will require you to remove that. So just keep in mind, again, think of it as a $1,500 insurance policy. It covers you in the event of something going wrong, because you just never know. You never know who's going to drill something into your stack. You never know when someone's not going to tighten that fitting down just right. Slope's not correct, so now you route out a connection. Again, it's just a safety device for you guys to kind of cover yourselves and your clients. Sizings are all available from us. And you may have seen this calculation sheet from others as well. A lot of the times, many of the vent manufacturers actually will say powered by US Draftco. So you send us a very simple sketch drawing that says, I have 3 appliances. They're manufacturer XYZ, 3 million BTUs each. They go up, over, around the bend. We'll do the calculation and provide you a nice report so that you can have that for your files. A few other topics for our manifold. Definitely going to have these as Wednesday webinars throughout the year as well. Our stairwell and elevator pressurization controls, we have changed how smoke control is done now. We are the first UL listed controller for stairwell and elevator pressurization. The other side of exhausting and having proper draft is having proper combustion air. This is something that's overlooked, especially in some of the colder climates where they just don't want to put big holes in their wall for makeup air. So we can do pressure-based combustion air systems for both mechanical rooms as well as commercial laundry spaces. Everything we do on the boiler side, we can do on the laundry side as well. High-res exhaust, this gets into, again, bathrooms, kitchens, laundry for condos, apartments, multi-family, multi-story. We can do the fans, the shafts, subducts, controls. KW, again, fireplaces, pizza ovens, coffee roasters, brew kettles, anything that's funky, you're just not sure how it's supposed to vent, give us a call. We'll most likely be able to help. And with that, I appreciate your time. Really hope this was beneficial. If you have any questions, I'm going to stick around for a few minutes. I know we do have a few here. Can we get a copy of the presentation? Absolutely. Anonymous, send me an email. Just send an email to info@ and we'll get that over to you. What is the advantage of my style inline fan versus the I won't use the brand, T paddle wheel style? So the strap-on paddle wheels type fan, depending on where it's installed, may or may not be a code violation. So if that is cut into, well, first off, it requires you to cut into a piece of listed material. That ruins the listing of that vent. So if you're using a listed pipe and you cut into it, it's no longer listed. So that's one major issue. If it is a true inline fan like ours, typically a paddle wheel just doesn't have the pressure capabilities versus a a backward curved impeller like ours does. So I would say that'd be the 2 first things off the top of my head, Tom, that I would say to that. Some boiler manufacturers list ASTM as approved for PVC. So yeah, so back to the PVC, that's kind of the end around, and I'm going to try and say this without offending boiler manufacturers. So the way to get around, or the way it's gotten around, is that because the pipe itself is not listed as UL 1738, it now has to be listed as part of the appliance. And so the appliance goes in and gets it tested with that, with the PVC or with CPVC. And that's fine. Again, if that's what the manufacturer allows and that's what they recommend, then that's what you should be doing. My personal concern is, again, it has not been listed and tested to, um, you know, as a vent system. And so it kind of started as in the, condensing furnace where fluid temperatures are 100 degrees, and then it got into condensing water heaters where it's 105, 110. Now you're starting to put it on boiler systems, and it's just going to be a low temp system until 3 years from now. The operator decides, well, now we're going to add a radiator to the system, or now we're going to change, or the secretary's too cold, and so now we have to turn the temperature output up. And it really limits what that boiler system can do based on saving, some money on. Now, I get it, PVC is cheaper. Although I say that up after about 6 to 8 inch, PVC is not that much cheaper. And again, in order to do that, if you look into those manufacturers, you have to use the special glues, you have to use the special primers. And again, 8-inch pipe is heavy. It's hard to install. It takes long. It takes more to hang. It's again, and I have no dog in the fight when it comes to pipe. I know I have several pipe manufacturers that have joined us today, and I'm sure they have a better explanation than I do. But as a personal standpoint, I just don't like using PVC because it's not intended to be used as vent material, even though the manufacturers are saying you can do it. I always say there's a lot of things you can do that you shouldn't. So I guess that would be my answer to that, Calvin. Hopefully that clarifies that. What do I recommend to prevent the exhaust gases to escape from the condensate drain located when the P-trap dies out? So basically, what do we recommend to prevent exhaust gases escaping? So again, if you're maintaining that negative, then that won't be an issue. If you're doing it naturally, like a positive sidewall, yeah, that is difficult. You definitely need to keep that P-trap primed. That's probably not a good answer, Eugene, but it's that's the best I've got right now off the top of my head. But like I said, the best way to do it would just be, plan for a negative, especially if you're common venting. We're going to keep that system negative. And then what material is a sensing tube? Our tubing it's a silicone. It's a high temp silicone. How often does the tube need to be cleaned or checked? The way we position the transducer, any liquid that does kind of get in there should drain right back out into the stack. So it shouldn't have to be, again, if you're getting random readings out, we'll have tech support will have you check that as part of the troubleshooting. But for the most part, we don't have that issue. Now, if you're putting it into a vent system, we always recommend the transducers higher than the tubing sensing point. So that is something to keep in mind as well. So again, if you would like a copy of this presentation, shoot me an email or shoot the email to info@rmmanifold. We'll get that over to you. Just want to make sure I didn't miss any questions here. Yeah, looks like we're good. So I'll stick around for a few more minutes if there is any others that pop up. Otherwise, again, really appreciate it. And just again, be on the lookout for the next one. Probably going to be late May, early June for our next webinar. So thanks again. Have a great afternoon.